This video was filmed using a beaker instead of a volumetric flask. The difference between using a volumetric flask and a graduated pipette to measure volume is that the volumetric flask is better used to measure a single volume. This would be ideal for performing a dilution. Using the graduated pipette with some simple math, we came up with the total volume of our dilution without a volumetric flask. To measure the total volume of the stock solution in the water, we took initial and final volumes on the graduated pipette, then added the total volume of the solution in water. While the results were the same, the experiment would have been easier if we had used the volumetric flask. The dilution is started by pouring in 20% sugar solution and pouring water. The final goal is to dilute the sugar solution with the water to create a lesser percent solution. For this first solution, our goal is to decrease the concentration to 10%.
First, we rinse the pipette to ensure that we don't accidentally dilute our solution. Now that we have our sugar mixture, we determine the volume by using a graduated pipette. When the solution is drawn into the pipette, the water molecules adhere to the sides of the glass, forming a curve, which is called a meniscus. The correct way to read the meniscus is to hold it up at eye level and read the volume from where the bottom of the meniscus sits. To obtain accuracy, you will write down the calculation with one more decimal place added to the number. We will measure how much volume we took up with the pipette by first getting an initial volume of the solution. After putting the solution we need in the beaker, we will take the volume of what is left. Again, we will refer to the meniscus. Now that we have our initial and final volumes, we will use this equation to determine the volume.
Next, we will determine the volume of the water we are about to add to dilute the solution.
For this, we calculate both an initial and final volume and use the same formula as for the solution. We add the water, diluting the solution. We then record the final volume to be 7.82 milliliters.
Now it is time to calculate the final concentration of this solution. We will use this equation. C1 is our initial concentration, which is a 20% sugar stock solution. We multiply that by V1, which is our volume of the solution given by 6.73 milliliters. We want to solve for the concentration of the new diluted solution, which is C2. In order to do that, we will go ahead and divide by V2, our final volume given by 13.56 milliliters. After doing the math, our final concentration is 9.96%. Since we added more water, our concentration decreased relative to the amount of water, resulting in a dilution.
These steps are repeated using our newly calculated 10% sugar solution. This differs from our original stock solution, which was a pre-diluted solution with the purpose of making lesser concentrated dilutions. We will use this to make a 5% sugar solution. Here are our calculations for our second dilution, showing that we got to a 5.25% concentration.
Here, we repeat these steps again with our now 5% sugar solution. Our final concentration of our last solution is 2.62%.
Our final step was to finish cleaning the lab after completing the experiment.